We can identify a chemical reaction through 4 factors. A change in state, color, the evolution of a gas, and a change in temperature are all signs that a reaction has happened. Additionally, the law of conservation of mass tells us that no matter can be made or destroyed in a chemical reaction, so if we observe any of these 4 factors, we can be certain a reaction has occurred. When it comes to writing a chemical reaction, the formula for magnesium, oxygen and magnesium oxide must be taken into account. When these reactants come together, they create magnesium oxide, which is written as Mg plus O2 right pointing arrow MgO. To accurately write a chemical reaction, the types and amounts of reactants and products must be taken into consideration, and these must be balanced. Knowing the properties of the elements and applying basic chemistry principles are essential for this task. Balancing a chemical reaction can be complex, but it is an essential part of understanding and studying chemistry. The process starts by drawing boxes around each formula of a chemical equation. It is important not to change anything inside those boxes. Once that is done, it is necessary to list the number of atoms of different elements present in the unbalanced equation. The balancing process then begins, starting with the compound that has the maximum number of atoms. This compound can be a reactant or a product, and the element with the maximum number of atoms must then be selected. Balancing the reaction correctly will ensure that the equation follows the law of conservation of mass. In order to be sure that a balanced chemical equation is truly balanced, the number of atoms of each element on both sides of the equation must be the same. This is accomplished by adding the appropriate coefficients before the formulas of the reactants and products. For example, if the equation is calcium carbonate plus HCl right pointing arrow calcium chloride plus H2O plus CO2, then 2 molecules of hydrogen chloride and 3 molecules of calcium carbonate must be present on the reactant side in order to yield 2 molecules of calcium chloride, 1 molecule of water and 1 molecule of carbon dioxide on the product side. To make a chemical equation even more informative, the physical states of the reactants and products should be stated. Gaseous, liquid, aqueous and solid reactants and products are represented by G, L, AQ, and S, respectively. The aqueous state is written if the reactant or product is present as a solution in water. In this session, we are going to learn about the 5 types of chemical reactions: combination, decomposition, displacement, double displacement, and redox reactions. Combination reactions happen when 2 or more substances react together to form a new compound, meaning all of the reactants are being used up. Decomposition reactions involve the breakdown of a single reactant into 2 or more products. Displacement reactions involve the replacement of one element with another. Double displacement reactions occur when 2 reactants exchange parts of their molecules to become 2 new compounds. Finally, redox reactions involve the transfer of electrons, where one reactant gains electrons while the other loses electrons. The combination reactions occur when 2 reactants combine to form a product. For example, when calcium oxide, also known as lime, reacts with water, it produces calcium hydroxide, also known as slaked lime, and releases a large amount of heat. Similarly, when calcium hydroxide reacts with carbon dioxide, it can form a thin layer of calcium carbonate on the walls. This reaction is what allows us to whitewash a building and give its walls a shiny finish. Interestingly, the same chemical formula for calcium carbonate is also the chemical formula for marble. Exothermic reactions are those that release energy in the form of heat. Examples include burning of natural gas, and decomposition of vegetable matter into compost. In these reactions, the products of the reaction are accompanied by the release of heat. This heat can be used to fuel a variety of everyday applications. Endothermic reactions are those which require energy input in the form of heat in order to proceed. One example of an endothermic reaction is the digestive process in our bodies. When consuming complex substances such as carbohydrates from foods like rice, potatoes, and bread, the body breaks them down into simpler substances such as glucose. Subsequently, glucose then combines with oxygen in the cells of our body to provide energy, which is also an endothermic reaction. Iron 2 sulfate is an example of a decomposition reaction, breaking down to ferric oxide, sulfur dioxide and sulfur trioxide when heated and its crystals change color. Calcium carbonate, when heated, also decomposes into calcium oxide, known as lime or quicklime, and carbon dioxide, which is used in the manufacture of cement. Thermal decomposition is a type of decomposition reaction achieved by applying heat. Electrolytic decomposition, or electrolysis, is a method for breaking down a compounds using electrical current. To demonstrate it, we can take a plastic mug and drill 2 holes at the base, then fit rubber stoppers in those holes and insert carbon electrodes to the stoppers. This is then connected to a 6-volt battery. The mug is then filled with water, and a few drops of dilute sulfuric acid are added to it. 2 test tubes filled with water are then inverted over the 2 carbon electrodes. When the current is switched on, we'll observe the formation of bubbles at both the electrodes. These bubbles will displace the water in the test tubes. We will observe hydrogen at the cathode and oxygen at the anode, and you'll notice that oxygen is twice the volume of hydrogen. Photolysis is a type of reaction in which light is used to cause a chemical change. In this case, halogen compounds decompose when exposed to sunlight. This kind of reaction is used in black and white photography and other scientific applications. The decomposition of the reactants requires energy in the form of heat, light, or electricity. Endothermic reactions are those which absorb energy during the reaction. The energy is usually in the form of heat, making the reaction endothermic. In a displacement reaction, one atom or group of atoms is replaced by another. Here are some examples. In the reaction between zinc and hydrochloric acid, zinc atoms are displaced by hydrogen atoms from the hydrochloric acid. In the reaction between silver nitrate and sodium chloride, silver atoms are displaced by chloride atoms from the sodium chloride. In the reaction between magnesium and copper sulfate, magnesium atoms are displaced by sulfur atoms from the copper sulfate. In a double displacement reaction, 2 ions from the reactants exchange, typically resulting in the formation of an insoluble product or precipitate. Often referred to as a precipitation reaction, the properties of the reactants are changed as one is exchanged for another, forming a new compound. This type of reaction can be used to identify and balance chemical equations by using the products. Today we will look at precipitation reactions to get a deeper understanding of double displacement reactions. Precipitation reactions occur when 2 solutions are combined together and an insoluble product is formed. Examples of precipitation reactions include the reaction between silver nitrate and sodium chloride to form solid silver chloride and sodium nitrate. We will also examine the reaction between calcium chloride and potassium phosphate to form solid calcium phosphate and potassium chloride. Understanding these reactions is important for a comprehensive understanding of double displacement reactions. Oxidation-reduction reactions, or redox reactions, are chemical reactions in which a reactant gains oxygen or loses hydrogen, or loses oxygen or gains hydrogen. Oxidation occurs when one reactant gains oxygen while the other is reduced, and reduction occurs when one reactant gains hydrogen while the other is oxidized. Redox reactions are important in many chemical processes such as cellular respiration and photosynthesis. Understanding redox reactions and their products helps us to understand many occurrences in the natural world. Redox reactions are any chemical reactions involving electrons in atoms or molecules losing or gaining electrons. Examples include combustion of methane, electrolysis of water, and the reaction of oxygen and glucose to form carbon dioxide and water. These reactions can be seen in everyday life, such as the rusting of iron or the reaction of hydrogen and oxygen to form water.